Hi there. I know it doesn't look it, but I've been working on this box for about 3 days now. Nothing is screwed down. And I just recently decided this is the layout I'm going to go for. The first couple days I was having a problem because I was trying to get this in this box. As you can see, can't install it that way because you won't be able to close the door, which only left me with this or what have you, but it wasn't working. And when I finally gave up on that, it all came together. It's going to be a simpler box because we're only going to have 120 into this, whereas before I was going to have to also bring 220 into it. So this will go in its own separate box, a 220 box, and we'll just connect it with these signal wires that turn it on and off and set the RPM. So the deal is we have some really thick plexiglass installed. It's about a ½ inch, a quarter, maybe a quarter. And that will allow me, there's 2 of them, and that will allow me to take it out, mount everything on the bench, and then install everything all at once. These will actually be sitting higher on standoffs. They won't be laying right there on the plastic. And I think I'll get away with that because it's going to be very well vented. I don't know if you can, yeah, you can. There's a mini parallel port openings on this box, same on the other side. Because originally I was going to use a 25-pin parallel port to run all this, but now we're going to be using Ethernet, which will just come through the side. But that got me thinking. I'll probably 3D print some louvers or whatever for the outside that'll attach on these, and this box will be able to just breathe without dust dropping in it. So I don't expect it to get too hot in here. These will obviously get warm. They're good for, I want to say 8? 7? Yeah. But we're not going to be pulling 7 amps on these. The motors, we have the most we're going to do is we're going to choke these down to maybe 3, almost 4 amps. That's all they're going to see. So I think I'm ready to start ripping this apart. Find a way to get these mounted. I don't have standoffs. I'm going to have to come up with something clever. And then we'll just work our way down to the till we get to the AC. And that's what we're going to do. Okay, we have most everything attached to our plexiglass, including the motors and the controller. Very solid. Pretty happy with that. So it's time to start thinking about wiring. And the best way to tackle a project like this is just start with what you know you need. And so that's what we're going to do. We're going to start up over here. I'll change the shot. Starting with the motors, each one of these has 12 connections. So you got power and ground. That goes to the dedicated power supply. In this case, 48 volts at 12 amps. These 4 are for the steppers. We'll get to those. And then the remainder, actually there's 4 more that go to this board. And then this is just a resistor. I just happen to have these 5 terminal block. I got a few of them. So we know we need power. We already established that from the dedicated power supply. So these are terminated on the back, and they will allow us to run our 48 volt up here, and then 4 jumps. Same for the ground, 4 jumps. That we know we need, so we're good there. The stepper motors, I've decided to run those directly. I'm not going to put a block on those. Mainly because it's one less disconnect in the circuit. So we're going to be using these for our stepper motors. This will go on the outside of the machine. This will go on the stepper motor wire. And in like that, out here into there. Don't need to worry about that at the moment. These other 4 are going to this board, so it's right there, no problem. And then the last 2 is just a resistor to set the current. So top level, this is all we really need up here for now. And then we'll jump to the power supplies. Okay, on the power side, it's not too complicated. So we do have AC 120 coming into both of these. We're not going to worry about that right now. We'll just leave room to install it. But what's really important in an application like this is you have to common your grounds. If you have your controller board taking a different path to ground than your motors, it probably won't work, or worse, it will work sometimes, which is as bad as it gets. So basically we're going to common the grounds on these 2 power supplies and then send this common up to the terminal blocks we were just looking at. This will only power the stepper motors, so we'll send that hot straight up. This is actually a 12 and a 5 volt power supply. We're going to use the 5 volt to power the controller board, and then this 12 volt will power the proximity sensors on each axis. And that's about all we need to concern ourselves with right now. There's more to do. But let's talk about cable management real quick. I only have 2 options for cable management, mainly because I'm tired of spending money on this project and I'm going to use what I have. So the first option is this. You can buy these at pretty much any hardware store, although I don't recommend it because they're really cheap. And when you screw this down, the plastic almost always breaks. These are nylon, very good quality. But the problem is, that's going to be a lot of screws, as you could imagine. The second option is this, which has double-sided tape on it. Very quick to apply. Again, do not buy the cheap ones. They'll let you down every time. I forget what brand these are, but they're very good quality. And I've actually attached it to a cutoff of this plexiglass. and we're going to let that sit for a few hours and see how it goes. It seems pretty robust. Another important part is termination of your conductors. Now you can take a bare wire, stuff it in here, screw it down. That's good for breadboarding, but if you want to keep the gremlins away, and you do, you kind of need to take a little effort. So in this application where it goes into a terminal block, strongly recommend you buy a kit like this. Basically these go on like so, and then you use the proper tool to crimp them down. And then those go in like that. I don't have one open here. There you go. And then you screw those down, and the conductor gets crushed in this tube, and that's pretty much as good as it gets. Nothing wrong with that. And then for the terminal block application, again, spend a little extra money, get yourself a kit like so. And the way these work is same deal. Over the conductor, use the proper crimping tool, lock them down. And these actually have heat shrink tubing on them, which is good. And then you can go ahead and plug those in. Worth the time and effort. You don't want to be chasing a loose connection. That's really as bad as it gets. So, there's good news and bad news. The good news is I'm done with the wiring. The bad news is, while I was doing a power on test before I put it into the controller box, turns out I had the power on this backwards, and I smoked my Ethernet smooth stepper. So, not much I can do about that. That was a costly mistake. It's going to take about a week for the part to show up. So, I'm pretty much done till then. See you next week.